So I was thinking about how to make games a bit more interesting. One thing that comes up quite often is, like in this example video I've already shown you once, we've got these kind of moving objects within the scene, and I wanted to do this it's kind of a moving platforms thing. So I've been on a little bit of a journey with it. I'll start here. What I've done is a very standard kind of thing, is that I've got a list for my sprites. I've called these things movers, and it's just a simple enough thing. We'll see what it actually does, and then just have a quick look at how it actually does the update on it. It's just this going backwards and forwards, and what I specify its x and y coordinate. I specify change x as 10, that's its speed horizontally, change y as 0. And down here I've got this hard coded here. I wanted it to be, it starts at x being 200 and it goes 100 this way, and when we get over 300, so 200 plus 100, 300, then it changes direction, moves back this way, and once it gets 100 the other way past, so 200 minus 100, it gets to 100, it changes back to going in the other direction. This is fine, it kind of works. Problem is, if we want to have a few of these, we're going to have a lot of hard-coded numbers, and it's going to be a little bit hard to keep track of, and we've got all this logic in the on-update thing. So this is a great opportunity to look at encapsulating all of this lot into a single class. So this is where I moved next. So this is kind of taking, you'll see this in examples that Python Arcade have done. Quite a lot of them have got their usual class mygame with the init setup and update and all the rest of it on draw. And then you'll see this before that, so you'll see a separate class. In this case it's for the player, and it's a way of just kind of having, well, quite very often what we're doing, it's like a sprite that does more than just a normal sprite does, and that's exactly what we're trying to achieve here. So there's my game with the init setup, draw and update, and this is my mover class, capital M by convention, and I make lowercase m objects out of this capital M class. So what I've done here, just for the sake of demonstration, I each time I make one of these, I give it a random XY position, which I set to be its center. I kind of have to remember the center in order to work out the bounds. You know, like I did before, I had it, the X position was 200, and so I needed, and the amplitude of movement was 100 each way, so I had to remember the 300, 100. So that's what I'm doing here. I'm using the origin to remember the center, and then the amplitude is how much I get it to move each time, and I've got a random speed as well. So this is just all setup stuff for any single mover that I make, and every one of them has got its own update class, which this basically, because it's actually a sprite, I should have pointed this out before, each mover is based on the sprite built-in class of Python Arcade. So it gets an image and it gets a scale just like every sprite we've ever made before. And we use this to kind of say when we initialize it, do all the other sprite initialization stuff that we need to do. And when we do an update, we say just do the normal update stuff that sprites do. But as well, we can do a little bit of maths. And this is basically that same thing. If self.center_x is greater than, well, I had 300 before because it was 200 plus 100. You can kind of see that. And changing the direction each time depending on which end of the bounds we've got to. So this should just put 1 in a random place. It should just work. There it is. Because you can see this tidied up this actual my game a whole lot more. Basically, I make this mover here. I don't have all of this configuration stuff has moved into this class, and the update stuff has all moved into here as well. And it makes it very easy as well if I want to make lots of them. So for I in range 10, so I'm just going to make 10 of them in this list, and I think that should give me 10 of them all up and running. It did not. Why is that? they're not all in the same place, are they? For iron range chain mover equals that self.mover's lint append mover. Oh, I didn't save it. Dumb. So save and close that and go again. Sorry, just an extra bit of fun in the video, so we should get 10 of them this time. And you can see the random positions, random amplitudes, random speeds. You don't have to make them random. I've just done that for demonstration purposes, just to show that. So all of these could be hard-coded with numbers as well. So this is fine. We could have some random things on the screen, but if you're doing like level design like this guy is doing, you want to position them exactly where you want and have them moving to the amplitude that you want. So I then decided to get a little bit more mathsy on it, and I wanted to have X and Y motion and also Y motion potentially as well, and do it all in one thing. So the best way to do that is with an ellipse. It also gives you a kind of like a relatively soft transition at the end. It doesn't just like go hard out backwards and forwards. You'll see what I mean in a minute. And I've done this as a parametric equation. So this is the it's kind of an angle 0 to 360, but it's in radians because maths is just better in radians. If you want to look at why radians are better than degrees, then Google it. So let's just have a quick look at what I actually did. So yeah, we've got a bit mathsy here. So every mover that I make now, I specify its position. I'm still doing it randomly, we'll see down there, but at least we don't have to do it randomly. We can specify a particular number. I also specify its amplitude horizontally and vertically. You can go back and refer to this. This is the maximum, this is the A, and this is the B. So the maximum, does this work? I haven't even tried it. No, never mind. Anyway, so these are the maximum things, and this is the speed at which it goes backwards and forwards. And I've also put a change angle to rotate it if I wanted to, which I don't think I have in this example. Just scroll over to the right. We'll do something about that in a minute. I have not changed that. So all of this is like the setup stuff. Let's go through it. So when I pass these parameters through to the mover sprite, I need to remember them. So we have to make them self dots. So each one then knows that it's got this parameter. So this A that was passed to it, is call that self.A, self.B, self.T. These are the values which were passed. Oh, self.T wasn't passed to it because T were always starting at 0. Rate is passed in, and I've calculated the position of it. You'll see this maths again in a minute. I'll just cover it then. Then we've got an update function, and the angle, effectively the 0 to 360, actually carries on past 360. I've got this rate, the amount that we add on each time to see how far around we've got. So this is the maths. Basically, this is calculating the position on that ellipse. If either A or B is 0, then we don't get the X or Y movement, whichever. And this just translates it to being centered at the position that we specified. All good. So when we make each moving object, we have to pass it those things. So the parameters were the X, the Y, the A, the B, the rate, and the change angle. It's a bit of a pig having it all in one line like this. So the conventional thing to do is you will see this in plenty of their examples, is you put each parameter that you're passing on a new line, just so that it's easier to read without having to scroll over to the right hand side or anything like that. So this is creating a new mover each time from this class, and then we are making 5 of them. And then this is the real advantage. We've got this relatively complex stuff going on here, but it's all encapsulated inside this mover class, and the on update is nice and clean and tidy, as is the setup. So let's just have a quick look at how that works. Forgive the bird noise. And what do we see? How many is it? We're going to see 5 of these things, and they should be moving kind of in a circular or elliptical kind of way. These two are not moving. This one's going up and down. Basically, this is because right here, when I specified the the rate, is that one? I think that's the rate. Yeah. It could end up as 0 because it's choosing a random value between -5 and 5. So these ones that we're seeing have got 0 values for both x and y. Quite a coincidence that these have got 2 values and this one has got, looks like just 1, and you can see the different rates. So let's just throw a few more in. So if I had, say, 100 of them, 100, well, this is going to be an absolute mess. Well, doesn't matter. You can kind of see what's going on here. So we can have them wherever we want. Okay, so lots of things going backwards and forwards, up and down, whatever we want to do. So for example, if I wanted them to not be rotating at all, I wanted them just to be going horizontally, I'm going to set the vertical parameter to be 0, and they'll all be going horizontally. We should see that. And then of course I could do this similar thing for doing the vertically as well. It's getting a little bit complicated at this point, but you know, if you're not sure exactly what's going on, just ask me. I'm more than happy to give you a little bit more guidance.